We are going to learn about the relationship between division and multiplication. This is an important concept for you to understand. We're going to see that multiplication and division are closely related. When we see an equation like 16 divided by 8 equals what? Another way to express this same question would be what number can be multiplied by 8 to equal 16? And the answer to both of those questions is 2. So I'm going to replace my question mark here with a 2, and we're going to look at this both ways. I can either look at this as a division problem of 16 divided by 8 equals 2, or working the other way, I can look at this and see that it's also true that 2 times 8 equals 16. This is true of all division and multiplication problems. Let's look at another example using 3 and 4. So if I have an equation like this, 3 times 4 equals what number? I could look at this as what is the product of 3 and 4? What's 3 times 4? But I could also turn the problem around and say what number can be divided by 4 to equal 3? Or what number can be divided by 3 to equal 4? And the answer to all of these questions is 12. So let me replace these numbers here with a 12. And we can see how these relationships work. So 3 times 4 equals 12. And then also 12 divided by 4 equals 3. And 12 divided by 3 equals 4. And so we can see here this relationship between multiplication and division. And we call this an inverse relationship. Multiplication and division have an inverse relationship. Let's do a little review of the names of these different pieces of our division problems. So the name of this first number here, the large number that we're dividing into smaller parts, this first number here is called our dividend. And then the number that we're dividing by is called the divisor. And our answer, this number over here, is called the quotient. And so there's something true about multiplication and division, and we would say it this way. When two numbers are divided into a whole number quotient, the quotient multiplied by the divisor will always equal the dividend. So let's look at that in a couple more ways here. So if we've got the dividend divided by the divisor equals the quotient, then it's always true that the quotient multiplied by the divisor equals the dividend. So looking at this in numbers, here's another example. If I have this 256 divided by 4 equals 64. Well, I can turn the problem the other way, and it's also true that 64 times 4 equals 256. So here we can see an example of the relationship between division and multiplication. Similarly, the product of two numbers, when divided by one of those numbers, will always equal the other. So let's take a look at this with numbers. If I have two numbers, like 4 and 6, and I look at the product of those two numbers, which is those two numbers multiplied together, I have 4 times 6 equals 24. Well, when these are divided, when 24 is divided by either one of these two numbers, the answer, or the quotient, will be the other number. So if I take the 24 and I divide it by 4, the quotient is 6. If I take the 24 and I divide it by 6, the quotient, or the answer to that division problem, is my other number, the 4. So another look at the inverse relationship between multiplication and division. This will help you do division if you have your multiplication tables really well memorized. So this means that by memorizing your multiplication tables, you have also memorized so many quotients to division problems. So if I had a problem like this, 72 divided by 9, without really even thinking about the division, I know that 9 times 8 equals 72. So I know the answer already is going to be 8 without really even giving it much thought of the division of 72 into 9 groups. I can just see that since I know 9 times 8 equals 72, then 72 divided by 9 equals 8, and similarly, 72 divided by 8 would also equal 9. So I have another one memorized just by knowing that 9 times 8 equals 72. I already know 2 of my division problems. This is another example of the relationship then. We'll look at 8 times 9 equals 72 so that we can just have these all in a group. 8 times 9 equals 72, 72 divided by 9 equals 8, and 72 divided by 8 equals 9. Let's look at an example of the relationship between division and multiplication with a problem having to do with pizza. So let's read our problem. It says a pizza is divided up into a certain number of slices so that each of the 8 people at the party can eat 3 pieces each. Into how many pieces was the pizza sliced? So when we first look at this problem and we see the word divided, so we think division, in the question, it seems to suggest that we're dealing with a division problem. But when we look at the equation to start solving this problem, we can look at it a little bit differently. So this problem is actually asking us what number, or how many total slices of pizza divided by 8 equals 3. And so we've got our total number of slices divided by 8 people at the party, and then we know that they had 3 slices per person. So we're actually looking at a problem that's similar to this, but we can't divide an unknown number into 8 groups. And so knowing what we know about the relationship between division and multiplication, we can turn this problem around and we can look at it as this. We can say, really what I'm looking for is the product of 8 and 3. If I know what 8 times 3 equals, then I'm going to know the answer to this problem here. So let's take a look. We've got 8 times 3 equals 24. And we know this relationship between division and multiplication, that the product then divided by any of the numbers, by either of the numbers, is going to equal the other number. So 8 times 3 equals 24, and in place of this question mark then, I can place a 24. And the division problem looks like this. 24 divided by 8 equals 3. And related to this in the same grouping is that 8 times 3 equals 24. So the answer to the question about the pizzas is that there had to be a total of 24 slices of pizza so that each of the 8 people at the party could have 3 slices of pizza.